You know that feeling when an idea just clicks? Not because it solves one little thing, but because it suddenly makes a dozen completely different things make perfect sense. Well, there's a point in science where you see so many coincidences that you have to stop and wonder, is this just an accident, or are we looking at a blueprint for how things actually work? Okay, let's dive in. This quote really gets to the heart of what we're talking about today. Imagine you're hearing the exact same melody, but you hear it first in a neuroscience lab, then in an engineering department, and then again in a paper about artificial intelligence. You'd pretty quickly realize that melody isn't random. It's the sound of some deep underlying truth. And we are on the hunt for one of those echoes. A powerful idea that keeps popping up in places you'd least expect. So there's actually a word for this: consilience. Honestly, it's the gold standard for proving something is real. Think of it like being a detective. If clues from three totally separate crime scenes with no connection to each other all point to the very same suspect, well, you've probably got your guy. It means a theory isn't just a clever trick for one problem. It's capturing a piece of reality itself. All right, so what is this echo that we're hearing? What's the one single truth that neuroscience, physics, and AI are all whispering about? Let's lay out the evidence. Okay, first clue. From neuroscience, our brains don't just think at one speed. They operate on different frequencies, right? You've got slow alpha waves for big picture context, faster beta waves for the task at hand, and super fast gamma waves for a sudden sound or sight. Clue number two, from engineering. The control systems for really complex things like self-driving cars use the exact same multi-scale idea to stay stable and not crash. And here's the kicker. The most advanced AIs are now, completely on their own, discovering this very same structure is the secret to thinking clearly. It's the same pattern, everywhere. So it's time to name our prime suspect, the architecture that seems to connect all these echoes. It's a framework called FGSGR, which stands for Frequency-Governed Self-Graph Reasoning. It's built on three really core pillars that line up perfectly with what we're seeing. The first pillar is time. FGSKGR gets that you can't think about everything at the same speed. Just like your brain, it splits information up into different frequency bands. This means it can chew on a long-term strategy and, at the very same time, react to something that just happened, all without getting confused. Second pillar, structure. See, human thought isn't a straight line. It's more like a spider web of connected ideas. A lot of AIs today use what's called chain of thought, which is like thinking on a railroad track. FGSGR is different. It builds a dynamic web, or a graph, which lets it explore multiple ideas at once and see how they connect. You know, how we actually think. And pillar number three is governance. If you've got all these different parts thinking at different speeds, you need a conductor for the orchestra. That's what governance is. It's the control system that makes sure the fast-thinking parts and the slow-thinking parts are all working together, pulling in the same direction to get things done safely and effectively. So you've got time, structure, and governance. But the real magic here isn't just having these three things in the same box. It's about how they're woven together into one single system. It's like baking a cake. You don't just have flour, sugar, and eggs sitting next to each other. You mix them together to create something totally new, something way more powerful than just the ingredients. Okay, this is where it gets really, really cool, because this unified system has a profound ability. It has a built-in way to tell good ideas from bad ones. It's almost like it can hear the sound of its own truth. So how on earth does that work? I mean, that's the million-dollar question, isn't it? Most AIs need a teacher, a ton of data labeled right or wrong by a human. So how can a system check its own work with no help? Well, the answer is just beautiful, and it comes straight out of physics. The whole thing works like a constant conversation between different levels. You've got the slow, strategic CEO level, that's the alpha layer. It's thinking about the big picture. Then you have the fast, tactical, frontline worker level, the gamma layer, reacting in milliseconds. Information flows up, but just as important, the strategy flows back down. This constant two-way street is called back-channeling. And here is the punchline: resonance as validation. When a quick idea from the frontline worker is in sync with the CEO's long-term strategy, their wave patterns line up. They reinforce each other. It's called constructive interference, and it creates a strong, clear signal. But what happens if the idea conflicts with the strategy? The waves are out of sync. They cancel each other out, creating noise, destructive interference. And you can see it perfectly right here. On the left, that's resonance. The waves are in harmony, creating one big, powerful signal. The system knows, yep, This is a good thought. Keep going. Now look at the right. It's a jumbled mess. The waves are fighting each other, creating noise. The system knows, nope, that's a dead end. Back up and try something else. In this system, truth literally has a clear, powerful sound. So it's an amazing theory, right? Sounds great on paper, but does it actually hold up in the real world? This is where we come full circle to that idea of consilience. The ultimate test is to see if this one single idea can solve real problems in a bunch of completely different worlds. And the evidence is pretty stunning. The range of applications is kind of mind-blowing. It's being used as a foundation for complex military command systems, for building cognitive twins that model a person's brain activity in healthcare, for augmented reality, for discovering new materials, and even a special version for doing high-level mathematical proofs. Let's just zoom in on one of those. Augmented reality. Think about what an AR headset has to do. It has cameras, motion sensors, microphones, all throwing data at it at different speeds. Well, that's exactly what the time component, USDF, is built for. The graph reasoning, that's perfect for understanding how all the objects in a room relate to each other. And back-channeling lets the system use high-level context, like knowing you want to pick up your coffee, to better predict where your hand is going. It's a perfect match. And what do you know? It's the same story in neuroscience. If you were building a cognitive model of a person, the frequency bands map directly to how we think. The slow alpha band, that's the deep stuff, your personality and core beliefs. The beta band, that's your current goal, like what you're focusing on right now. And the super fast gamma band, that tracks your in-the-moment emotions and attention. This isn't just a cute analogy. The structure is the same. So this all leads to the big so what? Why does this convergence, this consilience really matter? Well, it matters because it points the way to a whole new paradigm for building AI that we can actually trust. The fact that FGSGR works so well in so many different areas suggests it's not just another clever algorithm. It works because its core principles might just reflect how reality itself works. And when you build an AI on a foundation that's aligned with reality, it's just inherently going to be more robust and more trustworthy. It's like building a boat designed to flow with the current instead of fighting it. This changes how we think about AI's safety. The old way is what you could call the cop model. It's like putting a security guard at the end of an assembly line to catch the mistakes. It's reactive and it's always a step behind. FGSGR allows for a catalyst model. This is like redesigning the whole assembly line so it's impossible to make a mistake in the first place. It doesn't block bad thoughts. It creates a mental landscape where bad thoughts can't even form. And this is the molecule of thought idea. A true, coherent thought is like a stable crystal. All its parts fit together. It's strong. But a harmful or deceptive thought is inherently incoherent. It's like a badly built molecule with parts that are pushing against each other. It's unstable. In this framework, that instability is the lack of resonance. The thought literally can't hold itself together. It's not forbidden. It's just unsustainable. It just fizzles out. And that brings us right back to the beginning. The resonance is the validation. That echo we're hearing across neuroscience, engineering, and AI, it's not a coincidence. It's the sound of a fundamental principle. It suggests that truth and coherence aren't just nice ideas we want to program into AI. They might be properties of reality itself, like gravity. And maybe the challenge isn't to force AI to be true, but to finally build an architecture that can hear the truth that's been there all along.